All right, welcome back to another day of LeetCoding challenge. So today we're doing move zeros, where the input is an array, and we want to output such that we've moved all the zeros to the end of this array, and everything else gets squished to the front, retaining their order. So 1, 3, 12 is still 1, 3, 12, but all the zeros are at the end of it now. And the note is that we must do this in place without making a copy of the array. And two, we want to minimize the total number of operations, so make it as efficient as we can. So to do this, let's see, we have, I'm just going to copy the example 0, 1, 0, 3, 12. And this is a question where, the name of the question and how it's phrased kind of tricks you towards how your solution should be implemented, but it's not actually the most efficient solution. So in this case, the word move kind of, makes me assume we want to physically move this zero all the way to where it should be. So, we see the zero, there's a bigger number ahead of it, so we want to swap it. And then there's a 12 here, so we want to swap it again and make this 0 to make it all the way to the end. And now we scan again and there's another 0, so now we have to bubble this 0 up as well, and so on. But we can see that that's very inefficient because for every 0 that we see, we have to move it to the end of the array. So that's a lot of operations. So another way we can do this is, instead of moving, what if we can just overwrite safely? So what I mean by this is that we actually know exactly where each element should be in the final array. So for example, the first non-zero must always be here. The second non-zero must always be next. And the third non-zero must always be 12. And the rest of this we know are zeros, so we don't really care. So what we can do is, we can have a pointer here saying we need to overwrite this with the first non-zero. So then we start scanning. We see 1. We can overwrite that with 1 because we know that's where it belongs. And now we say, okay, we have to fill in this with the second one that we haven't read. So 0 we ignore. 3, we know that we should overwrite this, and we move on. And then here we keep going, and the last one is 12. So 12 is also not a 0, so here we can overwrite it. And then here we reach the end of reading our array. So what this means for everything else is that they have to be zeros. So in that way, we've only really scanned this array once to achieve the same effect. So let's try coding this out. We'll have our replace index equal to 0. And then we can loop through the rest. So for int, for every number, if that number is 0, we don't really care about it. But if that number is not 0, we want to overwrite at our replace index what that number is, because that's where it should belong. Now at the end of this, and you want to make sure we increase our replace index so we replace the correct one next time. And at the end of this, we are going to have our replace index basically end up here. So that means for replace index less than the end of the array, replace index plus plus nums at replace index is equal to 0. So here I just forgo like the int I part because we don't need to initialize another variable. We can continue using our replace index. Our exit condition is we read until the end of our array, and then we increment by 1 afterwards each time. So everything afterwards, we'll just fill it with zeros. So yeah, instead of moving zeros, we're just gonna, replace our non-zeros where they belong and just zero out the rest, and this should work. So let's try submitting. And it's a slow internet day. Judging accepted. Nice. So that's the end of today, and I'll see you on the next day.